So by the end of this video, you'll be able to describe what a relation is, and you'll then be able to determine whether a relation is a function or not. So to begin, we need to define the word relation, and all a relation does is it basically defines a relationship, hence the word relation. And a relation pairs input values, so inputs, with outputs. So in math, we have a lot of inputs and outputs that get paired. Anytime we do that, we are describing what's called a relation. And a relation can actually be represented in a variety of ways, and we're going to look at 5 ways specifically. So the first way that a relation can be represented is by using a mapping diagram. So when you have a mapping diagram, you have 2 ovals. You can see you have your inputs oval and your outputs oval. And what you do is you put all of your inputs and all of your outputs in. Notice I didn't repeat any numbers here, but I put all possible inputs in my input oval, all possible outputs in my output oval, and then all I do is map them. So what this diagram is saying is that the input 0 pairs with the output of -2. The input 0 pairs with the output of 1. Input 1 pairs with the output of 2. Input 2 pairs with an output of 1. And input 3 pairs with an output of 4. So you use ovals and lines to represent the connections between input values and output values. The second way that we can represent a relation is by using a graph. And you should know that graphs consist of coordinate points. And in those coordinate points, we have x, y values. So when we're plotting these points, we're actually plotting input-output pairs. Our input values are represented by the x values, and our output values are represented by the y values. So if you look at these different points, so this point right here is where x is 0, y is -2. So what this point is communicating is you have input 0 pairing with an output of -2. At this point here, we have the point x is 2, y is 1. So we can see we have the input of 2 pairs with the output of 1. So graphing is our second way of representing a relation. The third way to represent a relation is to utilize a table. So here you can see we have x and y values. Remember, your x values are your input values. Your y values are your output values. And what we can see here is the input of 1 pairs with the output of -2. Input -3 pairs with the output of -1. Input 1 pairs with the output of 0. Input 2 pairs with the output of 2. So all of these just list, these are my inputs, and they pair with these outputs over here. So again, another way to represent a relation. The fourth way that we can represent a relation is by utilizing coordinate points. And remember, when we have a point, we have our x, which represent our inputs, comma, our y, which represents our outputs. So in all of these points, it's input of x equals 1 results in an output of y equals -2. Input of -2 results in an output of 0. So coordinate points are another popular way to represent a relation. And then finally, our fifth way of representing a relation is that we can actually just describe it using words. So this says the same television station of X can be found on 3 different channels. So our television station is our input. We have an input of X, and it can be found on 3 different channels, which is our output. So we can also describe a relation in words. It's not incredibly popular, but it is something that we can do in addition to the coordinate plane and the coordinate points and the table and the mapping diagram. So what we're going to do now is we're going to use that definition of relation and expand it to discuss what a function is. So a function is a relation. So this is why we have to know the word relation first, because a function is a type of relation. But essentially what it is it's a specific type of relation. And we're going to talk about what that is. So a function is a relation where each input pairs with exactly one output value. So this means that for every input, or for every x, there is 1y. And we're going to look at that now with a couple of examples to determine whether a relation is a function or not a function. So here we have two different mapping diagrams. One of them is a function and one of them is not. So let's take a look. So we have to decide whether the following relation is a function or not. Please explain our answer. So something to remember is that the definition of a function says that each input has exactly one output. So if we look here at this first mapping diagram, input of 1 goes to 8, good, has one output. Input of 2 goes to 9, good, has one output. The input of 3, however, if we look at it, goes to two different outputs, 10 and 11. So this is a problem because it doesn't meet the definition of a function. The definition of a function says that each input has exactly one output. So here we're noticing, okay, the input of 3 has two outputs. What we would say is this is not a function because input 3 has two outputs. And you can even list those two outputs if you want, of 10 and 11. Then if we look down at example 2, we go through this same process. Input of -3 has an output of -1. Input of -1 has an output of -2. Input of 1, one output. Input of 2, one output. So this one is actually okay. Even though -3 and 1 share an output, that's actually okay. They can share an output. The big thing is that each input only goes to one output. So what we would say here is this is a function because each input goes to one output. So now let's take a look at some tables. So here in example 3, we can see that we have 4 different inputs here. So we have input 0, 1, 2, 3, and 4. Each input appears once. And what we can see is each input, so we have 0 goes to 8, 1 goes to 8, 2 goes to 8, 3 goes to 8, 4 goes to 8. And while it seems a little tricky because all of these outputs are repeating, this one is actually okay because each input only appears one time. Each input is going to one output. If we were to create a mapping diagram of this, we'd have 0, 1, 2, 3, and 4, and they would all have a single input line going to 8. That would be okay. So we say this is a function because each input goes to one output. Now if we look down here in example 4, what I notice is I have 5 of the same input value. So if I were to create a mapping diagram of this, I would have 8 in my inputs, then I would have 0, 1, 2, 3, and 4. So my inputs here, going to my outputs, 8 will go to 0, 1, 2, 3, and 4. So my input of 8 has 5 outputs. And what this means is that this is not a function because each input can only go to one output. And here we have an input going to 5 outputs. So we would say this is not a function because input 8 goes to 5 outputs. Okay, so here we have a graph. As we look at a graph, we need to remember that our x values are our inputs. So what we're looking for as we look at these graphs are that each input has exactly one output. So here, if I look at the input of 0, it has exactly one output of 8. Here, if I look at the input of 1, exactly one output of 6. If I look at the input of 2, exactly one output of 4. If I look at the input of 3, exactly one output. Exactly one output. What happens as I keep going is as I get to 5, the input of 5 has 2 outputs. That's a problem. So 5 has 2 outputs. And then if we keep looking, we'll notice input of 6, 1 output. Input of 7, again, has 2 outputs, so that's a problem. Input of 8 has 1, input of 9 has 1. So what we would state here is we would state that this is not a function because inputs 5 and 7 each have 2 outputs, which is a problem. That's not meeting the definition of a function. Now if we look at the next example, we look at input of -3, 1 output. Input of -2, 1 output. Input of -1, 1 output. Input of 0, 1 output. Input of 1, 1 output. So we can see that each input has exactly 1 output. So we would say this is a function because each input has exactly 1 output. Okay, so here we need to decide whether the relation with coordinate points is a function or not. So remember, when we're dealing with coordinate points, x is our input. So our x input part is what cannot repeat. Each input can only have 1 output. So what we're going to do here is we're going to look at our input. So I see an input of -2, -1, 0, 1, and 2. So what I'm noticing here is that each input appears once. -2 has 1 location it goes to, as does -1, 0, 1, and 2. And as a result, this is a function because each input has exactly 1 output. Remember, outputs can repeat. Inputs are what cannot repeat. Now, if we look down at the second example down here, I look and I see, okay, I have inputs of -2. I'm going to switch colors here. Hold on. -2, -1, -1, 0, 1, and 2. And what I notice here is I have 2 inputs of -1, and essentially -1 is going to 0 and to 1 as outputs. So I have 2 -1 inputs, which is a problem. So what this tells me is this is not a function because the input of -1 has 2 different outputs that it could possibly go to of 0 and 1. All right, and finally looking at this in words, the first one says each radio frequency in a listening area has exactly 1 radio station. So that exactly 1 part is telling us each input has exactly 1 output. So you would say this is a function because each input, which is the frequency, has exactly 1 output. Then if we look down at the bottom one, it says the same TV station X can be found on more than one channel Y. So this more than one part is telling us that each input goes to more than one output. So we would say this is not a function because the input goes to more than one output. So these last two slides are just going to show you a little trick that you can use when you're graphing and you have your relation as a graph, because what's something called the vertical line test can be used to determine if a relation represents a function. And essentially what this states is that a graph represents a function when no vertical line passes through more than one point on the graph. So if you look here at this first graph, we have a vertical line, and if we were to take that vertical line and run it through the entire graph, it only goes through one point at a time. So this one is in fact a function. Whereas the second one over here, if we take that vertical line and we run it through the graph, we notice that we have a spot where it goes through 2 points at once, telling us that it is not a function, telling us that the input x has a spot where it has two different outputs of y. So we're going to practice that on the next slide, and you can use that as you determine whether a graph is a function or not. So here you can see a variety of graphs. We're just going to take this vertical line and run it through and check to see which one is a function and which one is not. So here if we go through number 13, we're going to take this vertical line and run it through the whole graph. And what we notice here is that every time we hit a point, we're only going through 1 point at a time. What that tells us is every input has exactly one output. We're never crossing over 2 points at once. If we then go over to 14, again, notice at every point, I'm only going through 1 point at a time. There's never a point where I'm crossing that parabola or that graph at 2 spots. It's only crossing at 1 point at a time. So this one is also a function. If I go through number 16 here, again I notice, okay, as I'm going through, I'm only going through 1 point at a time. I'm never crossing in 2 places at once. And then as I get to 15, what I notice is there are multiple places. Here, I'm crossing through 2 points at once. Here, 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 here. No matter where I leave my line, I'm crossing through 2 points at once. So what this tells me is this one is a function, this one is a function, this one is a function, and this one is not, because this one does not pass the vertical line test.